Hello, everyone. This is Xiaoqing from University of Pittsburgh. Here, I will talk about our work on a tree-based model averaging framework approach for personalized treatment effect estimation from heterogeneous data sources. Estimating the conditional average treatment effects has been a hot topic, that is, the treatment effects of certain subgroups within the population. A common challenge for estimating CATE is a limited sample size. That's why people try to gather data from multiple sites or studies in the hope of borrowing information to improve estimation. However, there could be multiple issues. Firstly, data from different sources cannot be simply combined because they may come from highly different populations. Secondly, there could be privacy issue because we need to pull subject level data from multiple sites. Additionally, due to the nature of causal inference that the ground truth treatment effect cannot be observed in practice, estimating treatment effects is in general challenging. One way to tackle this problem is through the model averaging framework. Under this framework, data partners at local sites collaboratively build an analytical model under the orchestration of a coordinating site, which is one of the sites designated to communicate with all other sites, while keeping subject level data private and decentralized. To the best of our knowledge, currently, there is no established model averaging approach with the goal of improving the CATE estimation. Here, I'll give you a sketch of our proposed model averaging approach. Without loss of generality, we assume site 1 to be the target site or the coordinating site. For the local stage, we obtain the estimating CATE function from each local site respectively. After all these models have been fitted by each site, they are passed into site 1. So site 1 has access to its own data as well as all the local models. And then we are using these models from each site to create an augmented data from site 1. We predict the CATE of each subject at site 1 K times using models obtained from the K size. At last, in the ensemble stage, we propose to use an ensemble regression tree ET or an ensemble forest EF on the augmented data. We feed a model using the estimating treatment effect as the outcome and the site indicator plus the subject characteristics as the covariates. So this is going to be the final model to help us borrow information across sites. I will give you some visualization here. So when we fit an ensemble tree in the second stage, what we are getting is a tree with potential site subgroupings plus the partitions on the covariates. So those who are grouped into the same tree leaf can borrow information across the sites. That's how the information got crossed over from one site to another to improve the estimation and statistical efficiency. We also provide a consistency guarantee of the proposed ensemble forest estimator for the true treatment effect at the site 1. In our simulations, we compare the proposed ET and the EF with multiple existing model averaging or ensemble approaches. So the proposed ET and EF, as you can see, the pink and the red here, achieve competitive performance compared to other methods in all the settings. And to put our methods in a more specific context, for the real data application, we are interested in estimating the causal effects of an oxygen therapy treatment on patient survival among the ICU patients. We use the public eICU database to obtain the patients from 20 hospitals. The results here show that the proposed method has the largest gain in improving the survival rate, which is more promising than the local estimator and the observed treatments. Also, we provide some visualizations here for interpretation. So to summarize, we have proposed an efficient and interpretable tree-based model averaging framework to enhance the estimation of the CATE. And we also stress that our approach extends beyond causal inference to a general outcome of interest in other research problems where the data are heterogeneous. An R package for our framework was built and is available at GitHub. So that's it for the presentation. If you are interested in the details, please come to my poster session. Thank you for listening.